Hello guys, I'm a teacher Limboka Sajuga Masame. Welcome to Limboka Physics. We have a question below, and let's see how we can find the relationship between thickness, refractive index of different media, and the apparent depths. As we can see this relationship by considering the diagrammatical representations for the whole phenomena, where we have three immiscible liquids with different thickness. Object is placed at the bottoms, let's say a coin, and you will have two rays here, the normal and the ones that curved away from the normal towards the observer eye at air media. Let the refractive index for air medium as N4, and for the third media N3, N2, and N1. As for the case of three immiscible liquids, let us consider also the case for the two immiscible liquids. Also, we'll have a two thickness, refractive index, and let us assume these liquids are this media glass and waters for the purpose of the second equations, and this one is for the purpose of this first equation. Okay, as our final image will be image 2 as observed by observer eyes, and here our final image is image 3. We just to roughly check a relationship between apparent depth, the final apparent depth, the refractive index, and the thickness. We consider a two media. In order to get a final apparent depth, we must consider the two triangles that we will have incidence and the refracted angles, and that share a one common, that is opposite to the incidence angles. And from the diagrams here, we'll have a triangle A, O, and O1. And also for a second apparent depth, we will have a triangle that share the incidence and the refracted, that is triangle B, I1, and O2. Remember, incidence here is R1, as from these two angles are alternate angles, and also the refractory angles here is just the I2, as these angles are alternate angle. After taking such a look, let us use the relationship of tan, and for glass water interface, you have tan incidence 1 and tan R1, and also for water air interface, also we'll have tan R1, that is here, and for tan I2, that is here. And from the Snell laws, we know that for incidence 1, incidence 2, and incidence 3, and just fourth and other nth incidence with their respective refracted angles. Okay, for a small angle, we know that our sign is approximately equal to tan. Then we replace this sign with tan, and now we check a relationship between the two media. First, for glass water media, that is for I1 and R1, and second for water air media, that is for R1 and I2, as you can see here. Then we substitute this tan, and then common is cancelled out, and this for second media, common is cancelled out. Then we remain with equations 1, that for first apparent depth, and then here we remain with equation 2 for the last apparent depth. But we know that the I1b, when we define the I1b is equal to the apparent depth plus I1b is equal to just a thickness T2, that is AB, and the apparent depth IA, as you can see here. Then we substitute and we get equation 2, and the IB will be equal to, we substitute AB, that is equal to T2, as you can see from there, and the I1A that we substitute from the equation 1, as you can see here. Then we divide with refractive index 2. After doing a simple mathematics here, we'll have this apparent depth formula as N3 is equal to N of air, which is approximately equal to 1. Total shift is just taking the total depth, total thickness, minus with apparent depth. And here we'll have a general formula, as you can see here below. And also for the 3 media, you must be also considering the apparent depth triangle that with apparent depth 2 and apparent depth, the last apparent depth 3. This is where we have image 2 and image 3. And from here we know that we will consider the triangle CO3 and the I2 that is sharing the same common, that is opposite CO3, and we will have another triangle that is I1 and the I1 O2 and B, that is sharing this common opposite, that is B O2. And after identifying those triangles, it is for media 2 to media 3. It's media 2 to media 3. Let triangle B I1, triangle B A1 with O2. Then its respective angles for incidence and refracted, as you can see, for incidence and for refracted, as you can see, this corresponding angles. And also for a medium 3 to medium 4, medium 3 to medium 4, also you consider this triangle CI2 or 3 for respective incidence, as you can see, this is alternating angle, and respective refracted, as you can see, this is alternating angles. And then we have equations and tan R2 and tan I3. And when our eyes is close to normal, we know that it is a condition for the small angle. Our sin theta will be approximately equal to tan theta, and we'll apply the Snell laws of refractions and replacing all sin with tan. And then for medium 2 to medium 3 and medium 3 to medium 4, we will result with this equation. But we know that I2C is equal to I2B plus BC. This is I2B plus BC, that is equal to I2C. Then we substitute this I2B from the equations of when we solved for the 2 media. Then after substituting it, and we know that BC, that this is BC, is equal to that is a thickness 3, as you can see here. Then after substituting, doing a simple mathematics, we'll have a general formula, as you can see here below. And we know that for N4 is equal to N for air, and is approximately equal to 1. Then let us come and consider our questions. For question from exercise 3.3, exercise question 8, apparent positions for a 2 media, that is glass and water. We will have, as you can see, we substitute thickness, common thickness with 10 centimeter and the respective refractive index. Then our final answer is 14.17 centimeter. While for the 3 layers, also we'll substitute the refractive index with the respective thickness, and we will have 47.8 centimeter. Okay, thanks for watching. Please like, share, comment, subscribe. Don't